Okay, every year there's a different average score per problem of the free response. So I found these printouts that cover every single year. This is the information of the free response from 2010. So you can see that question number 1 had an average of 2.05 with a standard deviation of 1.25 points. Now that's out of the 4 points that you know that we have per problem. Look at this problem number 2. I wonder why that is so low. 0.78 points is the average amount that people got on that one. Crazy. But what we're interested in is the problem that we're about to go over, and it's problem number 6. The average on that was 1.92. That's the highest, the biggest number 6 that I've seen out of all of their years. So that's the most points on number 6 I've seen them give, and then with the standard deviation of 0.98. Okay, so let's see what you needed to do to get your points on this problem. Here we go. So here, this one was about the distance from the coast and then the amount of damage in the 3 different regions. So they wanted a graphical display of that. Here is one example. You did not have to do this type of graphical display. You could have even done like a line graph where maybe you defined what each group was and you did a line, you know, from one number to the other, okay, and then to here, and you did a line or whatever, okay, and so then you would essentially have 3 lines on this graph. I think doing the lines is probably going to be a little bit less time than drawing the bars, by the way. Okay, so I think that probably would have been faster because this took a lot of time, and so on. And then you would draw another line with a different type of texture for a different group. Okay, so hint, if you want straight lines, I use the lid of my calculator to make straight lines. So that's something that you have available to you. Okay, so I have seen people also switch this, and then they put a category that was the Gulf Coast, and then the Florida coast, and then the lower Atlantic. And then they would have like 5 bars for the Gulf Coast and 5 bars for Florida. While I think that, that's difficult to do. I think you probably would have gotten credit for that based on the criteria they set. But I think that's harder to tell what they're wanting you to see. Okay? Seeing it over time is probably, or distance is better. All right. Next, the way that you got points on this was this. First of all, it had to be well labeled and statistically valid. Like you couldn't have a pie chart. That would actually not be an okay one to do on this. And if it wasn't well labeled and statistically valid, that was automatically an I. Okay, an incomplete, no credit. The other way that you got your full credit is it had to have this information for 2 groups. It should have compared the damage across the regions and at the varying distances from the coast. So you should be able to compare the different regions and varying distances from the coast. So if you've got data that does that, you get full credit. If you have one of those missing, then you get partial credit. And again, if it's not well labeled, it's automatically wrong. Okay, so give yourself a point, half a point, or no points on that one. Next, question B. Describe differences and similarities in the damage amounts among the 3 regions. So I think it would be too generic if for the differences you just put the amount of damage is different per region. That's technically true, but I think I'm not sure if you would have gotten full credit for that. I want you to be more specific. For example, for the differences, Florida had the most damage across all distances. Okay? For almost every distance from the coast. For almost every distance from the coast, Florida had the most damage. And then I went ahead and said Gulf Coast had the next most and Lower Atlantic had the least. Okay. But as long as you said Florida had the most. Similarities, it was in all the regions, damages decreased as the distance from the coast increased. So as you got farther from the coast, the amount of damage in all of the categories, in all of the regions, decreased. Yes, ma'am. Gulf Coast and then you can, so you did it kind of like inequalities. So did you say this is the amount of damages? So you said damages in Florida is greater than the Gulf Coast is greater than Lower Atlantic. Yeah, that's probably okay. All right. Okay, so that is a whole point or not. Half a point would be if one of these ones you did not do satisfactorily. Okay, so if you maybe you didn't do the differences correctly and you did the similarities the same, that's a half a point. Okay, but you had to do both to get a full point. All right, now for the third point, it comes from part C is a half a point and part D is a half a point. So this down here is a half a point. Okay, so let's go back here. So if you read this here, they talked about ranking the damages. For example, in this category here, Florida had the most, Gulf Coast had the second most, and Lower Atlantic had the least. So you had that 1, 2, 3. It asked you to rank this category here. So Florida had the most, Gulf Coast had the second most, and Lower Atlantic had the third most. So this right here is what gets you a half of a point. So if you have those ranks correct, you got a half of a point. Okay? Now, you did need to average them. I had done the ranking of the averages, and so I later figured out that that was wrong. But you needed to do the average. So the average of the Gulf Coast line is 2. The average of the Florida line is 1.2, and the average of the Lower Atlantic was 2.8. Okay. All right, moving on. And by the way, those averages here, these things here did not have to be correct in order to get a half a point. What had to be correct to get a half a point was those 3 numbers right there. Okay, so here they said, okay, let's consider a hypothesis test. If we were to do a test, let's start off saying there is no difference in the damages amongst the 3 groups. That's our null hypothesis. And then the alternative says there is a difference in the damages amongst the 3 groups. Now, what kind of test that we have done sounds like something like that, where we're comparing the multiple groups and seeing if there's a difference in whatever? What kind of test have we done that sounds like that? Homogeneity, good. A chi-squared test of homogeneity. How is this, why would this not be considered chi-squared, though? What's different about this than chi-squared? Chi-squared is what kind of data? Proportions. Chi-squared is proportions, and these are not proportions. These are what? Averages. Okay. So see, we're in a whole new ball game at this point. But yet, it's similar to the thought process that we did when we learned our chi-squared stuff. So our null hypothesis is no difference amongst those averages, and our alternative is there is a difference. Now, they ask you to use a formula that they give you, fill in the blanks, and see what number you come up with. So they call, this is their little formula, and this you filled in from the previous page. This was the average from the Florida group from the previous page, and this was filled in from the previous page. Now let me ask you this. What happens what is this telling you right here? When in the Gulf Coast it had 2 minus 2, so the difference was 0. What is that essentially saying? That the what was predicted? Wait, what? Good. The observed was the same as what was expected. So this, in a sense, is a measurement of comparing the Gulf Coast observed and expected, comparing Florida's observed and expected, and comparing the lower Atlantic observed and expected, and then we are tallying up those differences. That's what chi-squared did. Do you remember that? And you see how they're all squared numbers? Okay, so it's so similar to chi-squared. I don't know what that 5's for, but anyway, it put it in there. So, so that's your differences observed minus expected. I don't know. Oh, beautiful. Thank you. Yeah, 5 is having to do with because of those 5 categories of distances. Perfect. Okay, excellent. Okay, so here we got this Q score, which is those kind of the totality of the discrepancies amongst those 5 regions, and we get this 6.4. Okay, hey, let me ask you this. The bigger this number, what does that mean? As Q gets bigger, what is that saying? The more varied, sort of. What is it telling me as Q gets bigger about the data, the observed and expected? What does it tell me if the observed and expected are 0? Observed minus expected 0. Then what? No difference. Very good. So the closer Q is to 0, so that's actually what I wrote here. This was just me kind of thinking. The closer Q is to 0, the closer that there was no difference in their average damage. Okay, moving on. That leads you into this data here. They then perform 1,000 simulations. Yes?
What if I got the numbers wrong?
Okay, good. So suppose that on this problem here, you had this right, but somehow you had this wrong, and then which meant that over here you missed this, so you got this number wrong. Well, then you would still miss that half. So you would be considered you would lose this 1/2 of a point, okay? However, we're about to use this number here, and if this number you have is wrong, but you use it correctly in part E, you can still get a full credit for part E. All right, so let's take a look. They do 1,000 simulations, and they get all of their Q statistics, and they here's a cumulative frequency table and the picture of it as well. So I'm interested in us making sure we know what this cumulative percent means. Okay, so here I have 4.8 and then 31. What is this saying? What does this cumulation of a percent mean? This is accumulating the amount of data. Okay, it's accumulating the amount of data. So do you see that by the bottom of the chart, we have accounted for 100% of the data. So right here, we've just had 48 samples, which is 4.8% of the data. Then we added 262 more samples to it, so that means we have now accounted for 31% of the data, and so on. So by the time we get to here, which this is of interest to me. Why is this line of interest to me? Because my 6.4 is the sample I got. So by the time I have done my sample, I have accumulated 96.1% of the data. Okay? And so there's kind of what's going on there. Which means, by the way, how much data is this part of my sample and up? If this is 96.1%, then this is 3.9%. That's where I had made a mathematical error. I said my top part was 2.3%. So I was wrong on that because that meant I didn't include the 6.4. And so we'll discuss that in a second. So let's come down here and look at the question it asks. Use these simulated values and the test statistic you calculated in part B, or part D. So that means use what you got in part D, whether it's right or wrong, and if you use it correctly, you're about to get full credit. But if you don't use it correctly, then you won't get your full credit. My value in part D was 6.4. So determine if the observed data, my 6.4, right there, determine if your 6.4 provides evidence of a significant difference in the distribution of hurricane damage amongst the three groups. So that to me sounds like we had that on the day before problem. Remember 2 days prior when we went over the free response question on Thursday? It was another one where we kind of figured out what that upper p-value was. And that's again what this one did. So I thought that was kind of good to have those back to back to point that out to you. So what is the p-value? The p-value is this probability of getting what? My sample or something more extreme if the null is true. So the probability of getting 6.4 or higher, I count how many items had that. There were 16 items plus 15 items plus 6 items plus 2 items for a total of 39 out of 1,000 items that had that. Therefore, my p-value, the probability of getting my sample results of 6.4 or something more extreme was 0.039. So was my sample unusual? My 6.4 was unusual? Yes. What would an unusual sample make me do? Reject this null hypothesis right here. This null hypothesis says there is no difference in the regions. And I'm going to reject that because my sample is unusual. All right, so that's what I wrote down here at the bottom. I said my sample results are in the top 3.9% of samples, and it is considered significant. I went ahead and put at the alpha of 0.05. Therefore, I think there is evidence of a significant difference in the distribution of hurricane damage results across the three coastal regions. Okay, so I got that all right. Again, you know what I did when I did mine was I boo-booed, and I did my p-value was just from here out. So my p-value was 2.3%. So my conclusion was the same, but I think that's a statistical error because that's an incorrect way of computing p-value. Because p-value is the probability of getting my sample, so I needed to include that 16 there. Okay, let's look at how you got credit on this one. So I come over here, I already kind of told you how you got credit on your part B, your part C and D, but here's how you got credit on part E. You had to have both of these things for a full credit. A valid quantification of the tail probability. You had to give a number value of that tail probability. You had to give a number value for the probability of getting your sample or something more extreme. And you had to make a conclusion in context that has to do with that probability you had gotten. So see, in your case, where if you had gotten part D wrong, but you calculated the p-value and made a conclusion correctly from that, you would get full credit on part E. Okay, how do we do? Now, so on average, if you are average, the nation's average for this problem was 1.92 with a standard deviation of 0.98. So maybe you could even see how many standard deviations you are above the mean. FYI, you could see. Okay, so let's check and see how you guys did on that.